equator geographic equator. There's a geographic axis. I'm just showing omega. I think it is understood. We know that axis is not actually that one. So slightly it will oval. So time being, let's consider that one. So now the Earth is also producing its own magnetic field. From where that magnetic field will come? So we have one very simplest idea that the core is made up of ions. And as the ions, as we know that electron revolves in a circular path, it will produce a magnetic field. So go back to this. So I is equal to Q by T, Q omega by 2 pi. If electron revolves in a circular path, it is in fact going to produce a magnetic field. Then what is the magnetic field is equal to mu naught I 2R. Mu naught 2R, what is I is equal to Q omega by 2 pi. There's a magnetic field at the center of that circular path. A revolving charge particle will produce a magnetic field. That's what here. So what is the core of the Earth? The core of the Earth will assume that made up of ions. Ions, that one. These ions, what is the state of Earth? The Earth is revolving. So as it revolves around its axis. So these ions also will rotate, no? So rotating charge particles will produce magnetic field. This was the one theory is what that is being published. So still some are telling may not be possible this also. Okay, so I think we are in still yet to know exact cause. Okay, the books what been to convince students what been they just say like okay take this idea. So what is the core of the earth? Will assume that made up of ions. That revolving ions will produce a magnetic field, and that is what Earth's magnetic field. Now, how to show that Earth's magnetic field? So when I go and check it, no, the north pole of the Earth. This will be the orientation of the bar magnet. So what all that Earth's magnetic field, no, we'll say that let's approximate it to be like a bar magnet. Then it is having a dipole moment. This one. So this will be north. This will be south. Okay, so the south pole of that. What is this, sir? Is there any bar magnet? No, I'm telling this one. The rotating ions inside the core of an earth will produce a magnetic field. That particular magnetic field open, since I know I know all the mathematics related to bar magnet. I'm replacing the earth's dipole moment by a bar magnet here. That I'll place it at center. That one, it's a very big giant magnet, and its dipole moment will be directed in the direction. So this is called like a now geomagnetic south. So the north, though the north pole of the bar magnet of Earth is here, what I'll call geomagnetic south. The reason for that, earlier they assumed that this will be the south of the bar magnet will be here near to the south, and the north will be towards north. And almost it went for 100 years. They did all everything. Then what happened later on? They realized by experiments, no, it's something reverse. It is. So the same convention we're calling. So the north pole of the bar magnet is near to the south. Still, I'll call that as a geomagnetic south, and this called like a geomagnetic north here. Reverse convention. And this will take the next magnetic equator. Now, why this magnetic equator? I think if you can remember, because it'll be very easy for us to describe the field on the equator on the axial line. So this particular thing is called like a magnetic axis. This is the geographic axis. Okay, this and there's a geographic equator like this. So presently, what happened? If you look at the data, no, it is making around 11.5 degrees. The dipole momentum of the angle between magnetic axis and the geographic axis, it is making an angle 11.5 degrees, and it's not a fixed constant. It is varying. Constant. It is varying. Sir, how it is? That's what we don't know. What is the reason? Means the core. What happened? The core what happened? It's spinning. Sir, it should spin about omega. No, it's having its own spin. Maybe after another some 20, 40,000 teachers, the physics teacher will be teaching with m bar along geographic equator. Are you able to get this one? So this particular m bar is not a fixed here, constant open. This the magnetic axis and the geographic axis, they are not the geographic axis is fixed here. Magnetic axis is not fixed. Constantly open will be rotating. We don't have any exact reason why such a thing happens here. And what is the m bar of the Earth's bar magnet? It is of order 8 into 10 to the power of 22 ampere meter square. Approximate, you can put it around. And typically, what is the field on the surface of the Earth produced by this bar magnet is of order 10 to the power of minus 4 Tesla, or it is called as 1 Gauss. So they have just brought a one unit, 1 Gauss. The 10 to the power of the field of the Earth, what happened is measured in terms of Gauss here, or 10 to the power of minus 4 Tesla. On the surface of the Earth, what is the magnetic field? It's called like a 1 Gauss, that one. And there's a dipole moment. And it's not a fixed 11.5 degrees, constant, it is increasing. Some 400, 500 years back, I think we are able to measure. At that point, what happened? It was different. And now the data, what we measure, is no different. So for every 500 years, we are able to see some appreciable change. So with that, they're able to say that the magnetic axis is not fixed, in fact, continuously be rotating. I think in NCERT book, he has given some specific data, like how it rotates everything. Let me. I think SUR might is there. Uh, for past for past 7.6 into 10 to the power of 17 years, it has rotated 171 reversal circle. Just I'll some phone call is there. I'll attend and. Rekha. Just some. Within 2 3 minutes I'll come back. Okay, sorry for disturbance. Some washing machine repair person has come and it got damaged severely. Okay, no. We were for in the span of years, no, 7.6 in 10 power 17, 171 reversals till now it has occurred here. And in SVM is telling the latest reversal occurred 10,000 years ago back. The latest reversal occurred 10,000 years. So like this is what is telling. So possibility of asking this data also. 10,000 years back. Okay, this is about the basic thing. So now how to study this magnetic field? So who are going to help this magnetic equator? And next what we have, the magnetic axis. With the help of these things we are going to, and we already know the B bar due to Hertz magnet. So B bar due to bar magnet. So shall we bring the same idea? So just I'll ask you one best question. What is the magnetic field at the magnetic equator? I'll slowly deviate from this. So let me put another diagram. Now you should be very careful about numericals of these application part. In books or open, to some extent they are discussed. So there's a magnetic axis. There's a geographic axis. There's a bar magnet. So where do the magnetic equator will come here? Let me ask you some simplest questions here. So at point 1, what is the magnetic field here? And we know m bar is like this. So can you make a guess of what should be the direction of B bar there? B bar should be directed opposite to M bar, no? So B1 bar will be like this. What about the field strength at this point? So we'll take this is B1, this is B2. What about the field strength at point 3? Somewhere on the surface. It should be like this. Able to understand? No? On the equator, I want the magnetic field. So we know that radius is R, no? It is. So what is the value of B2? B2 will be mu naught M. What is M? I already gave the value. This should be equal to 4 pi R cube. What is R? R is the radius of the earth. Please do understand these things. So these are, which will help you a lot in numericals. Then what is the field strength at point 1? Magnitude. Because this will become axis, no? Magnetic axis. And what is that blue color one? The blue color is what? Magnetic equator. Sir, can we find out anywhere here? Point 4, anywhere here? And tell me what I should do. Anywhere at point 4. So again, I'll go for the approach like this. You have to work out some set of numericals. Not only this, we'll go for some arbitrary point. There's a bar magnet. Where is the arbitrary point? Arbitrary point, I'll pick up here. On the magnetic equator, let's on the geographical equator, we'll take it. Yeah, come for this. What is about the point 4? Point 4 is here. Already 1, 2, 3 we have seen. So this is the geographic equator. No, how to calculate this? This angle is what I'll define this one. If you know this angle and you know these distances are, so there are two components will be there. No, one B parallel, another will be B perpendicular. How B parallel should be along B4, another B parallel. So B parallel will be like this, and B perpendicular will be like this. So B4 will come somewhere here, and this is the angle phi you would write. So what is the value of B parallel in terms of M? Go back to the dipole moment, and you can work out. So like that, I can find out anywhere on the surface using that electric dipole moment or the magnetic dipole moment due to bar magnet, or the B bar due to bar magnet surrounding it. We have derived one similar to electric dipole. With the help of that, I can find out the field. Can be asked. So how do they define? We define point 4 by latitude and longitude. With the help of that, what you should locate that particular point and you should find out the angle between M bar and R bar. So here small r, what happens? Small r will become capital R. And like this, I can find out now the field at any point on the surface of the earth. The method what we know with the help of that. Got the idea, no? So so we are in now best position, no? What we find out the field due to bar magnet, it is helping us a lot. With the help of that weapon, we are able to analyze these conditions clearly. They're the basic thing. Okay, now next, what is another problem? You look at the way I'm showing things here. So let's check the B bar on the surface of the earth. So if you go for on the surface of the earth, I will put in next page. No, let's come for. So only magnetic equator, I'll show it. Huh? Geographic equator is of no use. How the B bar will be directed here. We want bar magnet. First point 1, how B bar will be. Shall we put like this? B1 will be. What about at point 2? Let me go for some points. 1, 2, 3. What about the field at all these particular points? B1 will be like this. B2 will come like this here. This will be B3. This will be B4. And B5 will be like this. B6 will come. Look at the direction of magnetic field at various points. Sir, how you can say this? How you can say this? just go back to the just now what I discussed. No, somewhere on the magnetic equator, B parallel will be along position vector. B perpendicular should be perpendicular position. The resultant of these two will be before here. No, will I agree this? And what should be the on axis? How on axis should be along B bar or along M bar. On the magnetic equator should be opposite to M bar. Now you can say, how come, sir, here you are showing down? How come you are showing down here? So why it is down? So you can see this again, put R bar. B parallel and B parallel, the resultant of that, south pole will be very nearer to point A. For point 234, the north pole will be nearer. So definitely open the field here will be, the resultant field will be in this direction. Simple mathematics, nothing to do big. Simple mathematics here. So therefore, where it will be parallel to the surface of the earth, shall I say at magnetic equator, where it will be perpendicular to the earth, surface of the earth at magnetic axis. Okay, now I'll come to the one point. The angle made by the B bar with the surface of the earth is what I'll call it as a dip. So what is a dip? How to define dip? The angle made by resultant field with the surface of the earth. That is called like a dip here. Means now, if you suspend a bar magnet here, tell me how it will get oriented. So I'll show point one, surface of the earth, no? So and there's a point one. How B bar at point one, B bar, B1 bar will be like this. The field at point one will be like this. Suspend a bar magnet, how the bar magnet will align. If you suspend a bar magnet freely, sir, how you suspend bar magnet freely? I'll tie some small string about an axis passing through the center. Then when I suspend it, no, the bar magnet will align itself like this. Though I suspended its center, it will align itself. And what is the property of bar magnet? It will align itself such that the M bar of bar magnet should be along B1 bar. Though you tied a string here, it will align itself in this way at point 1. Now at point 2, at point 2, how B bar? At point 2, the B bar is directed vertically into the plane. I think point 10, sorry. So if you suspend a bar magnet here, the bar magnet will align what is it? Because there is a property of bar magnet, no? It's a freely suspended bar magnet. Please try to understand. It is a freely suspended bar magnet. Or so like a suspended bar magnet, how you do suspend, you'll get confusion. So let me bring a bar magnet which is suspended about axis O. Okay, agreed. I'll remove this string. Or what happened? I'll call like a dip circle. It is. This is a setup. So this bar magnet what happened is mounted about point 2. And it can rotate about an axis passing through point 2. Okay, agreed, no? So when I keep this particular instrument here, when I keep it this instrument here, so how do the north pole of the bar magnet will align like this. Here the north pole will get aligned like this here. So this instrument, this particular bar magnet is free to rotate in which XY plane? Able to understand? I think you have just write dip circle something, no? So these are some diagrams I'm just keeping. So the dip circle, you have to keep it here, no? If you just place it. So how the orientation of the bar magnet in dip circle will be like this. Same dip circle you keep it, the north pole will come down. This is like a stand. You just keep it on the surface of the earth. The bar magnet can rotate in XY plane. So it will get oriented. About point O, it can rotate. Where all of you able to understand? Bar magnet. About point O or Z axis. Now, if you keep bar magnet at 0.5, how it will be oriented? Or the dip circle at 0.5. If you keep it at 0.5, so how the field everywhere here will be tangential, no, to the surface of the earth. There's a B bar of the earth, B5. If you keep bar magnet here, it will get aligned itself tangential to the field. So the dip circle here, how the bar magnet, it will align itself in the direction n bar. M bar of bar magnet will be along this particular thing. Able to understand now? This is called like a dip circle. So what is a dip circle? It contains a small tiny magnet which can rotate in vertical plane. What is XY is a vertical plane. Bar magnet will rotate about point or Z axis or in XY plane. Able to understand now? So there's a nature of the B bar is what we are able to tell. So what is the biggest problem what we have? The B bar is not constant at so but you wrote 10 to the power of minus 4 Tesla. That is average. The value will like if at some point it become 5 into 10 to the power 5 Gauss. Some points it will be 6 Gauss. Sometimes it will be 4.5 Gauss, like that. On an average we are putting of order it is, not exact that value. So at different points on the surface of the earth, the magnitude of B bar will be different, but order is 1 Gauss, 10 to the power of minus 4 Tesla. And what is another problem we are facing? The 90 degree. You can see here, this directed perpendicular to surface of the, means here if you go and stand at point 1, this will become vertically up towards sky. What about here? It will be, the B bar will be directed into the plane of the earth. Here B bar will be tangential to earth and it makes an angle. So what is the biggest problem we are having? At different points, both the magnitude and directions are different. So we need a method to predict both magnitude and direction. This one. Okay, now once again I'm putting, what is this? This called like there's a north pole. I'll indicate. Though it's a north pole of the bar magnet is there, I'll call still this is what? Geomagnetic south. Wrong convention. Wrong convention it is. And what about this? This called like a, though south pole of Earth's bar magnet is near to the north pole, but still what's happened? We are calling that geomagnetic north here. This is geographic north. Actually, what we should call magnetic north, I should call, but still what I'm calling geomagnetic south only. Though north pole of bar magnet is there, still I'll call it as geomagnetic south only. It's a wrong convention. It's a wrong convention. And that 11.5 degrees is not constant. So there's a one. So will it be only on right hand side? It will be there on left hand side also. Just for our convenient purpose, I just shown only on the right hand side. Means even the similar thing is what variation you have to see here also. Magnetic equator. Just I shown on one side. There's a one basic idea. Now how to measure that particular magnetic field. So whose help? I'm going to take first a freely suspended bar magnet. So what you should do here, suppose like sir, I want to measure the magnetic field at my ohm, in my ohm. So what you should do, take a bar magnet, you suspend it about an axis passing through its center and perpendicular to plane. So you can do one thing, take a thread. This is books not explained, that's why you find very difficult. Huh? Please do try to understand things. So there's a string. You are going to hold it or suspend it. So this we know it's a north pole. This is south pole. You are going to suspend it like this. No? Then, so what it says, it should be here, no? Come for this one. You hold it like this. Then particular bar magnet, what happened? Now, shall I say it is present in the Earth's magnetic field, and what position the bar magnet likes very much. It is like it's free to rotate. Free to rotate about which axis? In which plane it is free to rotate? You know enough rotation mechanics. It can rotate about the string, no? It can rotate about the string only. Suppose if you define this as x and y axis, about which axis it can rotate? This particular, if you suspend a bar magnet release, it can rotate about what? Y axis only. Because the string will not permit it to rotate about x or z axis. Am I right? If you bring this dip circle, I need these two equipments. Without this, not possible to measure the Earth's field. Using dip circle, now what about this bar magnet? It is made to rotate only about what? About z axis. The bar magnet can rotate about z axis passing through O. So in which plane it can rotate now? XY plane. What about here? It can rotate about only Y axis. Here, freely suspended bar magnet can rotate about Y axis only or about string. Okay, now so these two equipment, this is called like a dip circle. So this is 0, 90, 90, and this is 0. Like this, I'll take the coordinate system to measure that particular angles. These are the two equipments which I'm using. Now I'll suspend a bar magnet. So the bar magnet is in equilibrium. If you slightly displace this above the string, it is going to oscillate. Slightly displaced means if there's a string, there's a bar magnet. If I slightly displace it, displace in the sense, it will come like this. Then in what action the torque will act? I think I have to draw a better diagram. Come forward. Able to understand this? I don't know what. It's a small diagram. No, I'll displace it. So slightly I displaced it, theta. Then open, I see that some torque will act. The torque what happen will bring it back to original position. This shows that there is some field is there. And away the field is like this. If you slightly displace, how M bar will act. The M bar earlier for this position, M bar, and there's the external B bar. So when you slightly displace, the M bar will come like this. So how the displacement given theta like this, how the torque will act here. I think since you are very good in dipole moment earlier, that idea I'm taking help here. How the torque will act. How with the angular displacement like this here. So what makes the bar magnet again to come back? There's some field. What is this field? This is the horizontal component of field. The horizontal component of magnetic field weapon will bring the bar magnet back to its equilibrium position. So definitely, who will have influence on this suspended bar magnet? Which field? Horizontal vertical component. Horizontal magnetic field will come into picture. Though vertical component cannot do anything for this because it cannot rotate about what? Z or X axis. Will agree this? And what about dip circle? Who will have influence on it? The total magnetic field here. The dip circle here, the total magnetic field. What about here? The horizontal magnetic field. So like this now I have brought a method. Can I find out this horizontal component of Earth's magnetic field? S. Using what? Vibration magnetometer. Go back. I wrote BH. So all these are interlinked. I don't know where it is. Okay, no, here. So how to measure BH? It's very simple. I know M1. Then here remove M2. Then I'll measure time period. I know moment of inertia M1. Then BH I'll come to know. So can we measure the Earth's horizontal component of magnetic field by using vibration magnetometer? By using this setup. Agree this? So what is BH? BH is measured using vibration magnetometer. So I'll write all these things. Let it be here only. Using vibration magnetometer. So I know one component BH. What about this direction? We have some directions no here, and that at every point will be different. So therefore what I do is I'll take help of these two equipment. Let me come into the picture. Now the in which plane it is lying, shall I say the plane in which the freely suspended bar magnet lies, that is called like a magnetic meridian. Will I agree? So I'll define the meridian words. First, magnetic meridian. The plane in which a freely vertical plane, no? Sorry, this a vertical plane in which a freely suspended lies. This is called like a magnetic meridian. Now, how to identify magnetic magnet? Sir, in my home, I want to identify magnet. You just do one thing: take bar magnet, tie light some thread, then hold it. The vertical plane in which this bar magnet lies, that is the magnetic meridian. Agreed, all of you? I think it's quite simple. This is the only method available to identify magnetic meridian. Then what about the geographic meridian? Geographic meridian means all of you please do concentrate in books. You don't have just only some diagram and one formula. You find very difficult. Huh? You don't have much information, not even in much in internet, because there's a totally pure lab based one. Since I did lab, so I'm having good idea. Otherwise, if I didn't do lab, no, I would have just ended up with only formulas. I say, okay, fine, remember. So what is geographic meridian? It's a vertical plane in which geographic north and south lies. So this at every point again this will be different. Suppose in your home, identify geography north and south and bring that plane. This one. And let's come for this. At different points, the direction of magnetic field will be different. No? So if you go for the Earth's magnetic field, okay, meridian, okay, all of you, meridian, meridian. So don't bother that word. What is meridian? A vertical plane. Like this, we have magnetic meridian, geographic meridian. Why we are bringing all this one? If you look at the basic Earth's magnetic field, this is a bar magnet. So how the lines of force? The lines of force will be like this. I'm showing few. There's a three-dimensional you are supposed to imagine. Okay, this will be the lines of force. So there's a north pole, south pole. Rough diagram. For better diagram, type in Google. Huh? Okay, this is the lines of force will be directed. So look at everywhere the B bar. B bar, I think direction also will be different. No? Magnitude will be different. Somewhere it will be parallel to us, somewhere perpendicular to us, somewhere it will make different angles. So I'll suspend a bar magnet. And the bar magnet, what now freely suspended bar magnet will be present in Earth's magnetic field. And it will try to orient in stable equilibrium. So how to obtain the magnetic meridian means just suspend a bar magnet, the plane in which the freely suspended bar magnet is located. No, that vertical plane is called as a magnetic meridian. Finish all very simple. So I just show the B bar, B bar of the Earth. So what is this? O is OA1, C1, D1. This is the magnetic meridian. What is this B bar? Because if you suspend any bar magnet, the bar magnet I'll show for you because you find it a little bit easier. Okay, I get this. And what is this B? B due to Earth. It will end. So what is this plane? So that particular bar magnet lies in this OA1 C1. Books they're shown one arrow like this. I'm just putting this one. So what is this bar magnet? So I'll put bar magnet. Lies in vertical plane OA1 C1D. And what is the magnetic meridian? The magnetic meridian is OA1 C1D1. We do have geographic meridian. It should come from here. This OA2 C2, let it be only D. Now, what is a geographic median? OA to C to D. And this will be the geographic north. This is a magnitude. And the angle between these two, is called as a declination. Theta will call it. And the angle, and what is OA1? OA1? OA1 is surface of the earth. Please, this is something very important, because when you go to numerical, no, you need all this background. OA1 is surface of the earth, and this is the dip. How to measure theta? How to measure theta? I'll locate geographic median. Sir, how do I locate geographic median? I know what is the north and south, geography north and south. Then I'll just put one paper or cardboard in that particular plane. Then I'll suspend a bar magnet. The bar magnet, what when the suspended bar magnet will make some angle with this plane. So the plane in which bar magnet lies, there's a magnetic median. So now the angle made by B bar with geographic median will become theta. That is called like a declination. Why do you bring the theta? Look at this. This is a geographic north, no? These two dots, I'll put it. So what is this? Geographic north, and this is at different points. What happen? Like at different point, the B bar what happen will make different angle with geographic north, and so that we are expressing like this. What is a dip? Already you know that one. You can see from here how B bar means like at this particular point how the diagram will be. This bar magnet will be along OD here. At magnetic equator, how this bar magnet will be along OA1. So what is OD? OD is a perpendicular to surface of the earth, or normal to surface of the earth. Agree this one. So these are the like this will define. And now, so this B, I'll resolve it. If I resolve it B, I'll get two components, one vertical component, the other horizontal. Do we know BH? Yes. How do I find out BH? Vibration magnetometer. How do I find out dip? Delta. This dip is called as delta. This is found by using determined using dip circle. What about theta? How do I find out? By freely suspended bar magnet. Angle made by freely suspended bar magnet with geographic median is what? Declination, as I can find out. Now BH, horizontal component of Earth's magnetic field. How do I find out? I'll give name. Horizontal component of magnetic field. What is the symbol? BH. How do I find out this? Using vibration magnetometer. All this, some symbols I'm giving, very important. Now, determine found using vibration. Don't ask me, sir, why you are finding out this, because in my day-to-day life, I don't know, I don't have any use of this magnetism. Anybody use morning, you get up and you check what is the magnetic field, then you start your life. or you take breakfast by looking at magnetic field, nothing, no, then what is use of learning? But if you look at the forecast, the rain, the climate forecast, we need all this magnetic field. This magnetic field is something, gravitational field, magnetic field, all this is very important in predicting the the weather. Is very, very essential. And okay, now we have some sort of this one. Even if you worst case, what happened, the sailor means, I think, okay, all of you, the one who will sail in the ships, that one, for them what happened, this was the only, what happened, the magnetic needle was the only instrument which is used to predict the direction. So even if you go for the flight, no, if you get into aeroplane, how do I get the direction? I should take help of magnetic field only. If I don't know magnetic field, I cannot say that the plane in which direction I'm going. So for flights, the magnetic field, and the for ships, what happen, the magnetic field is very important. So I should know how to measure magnetic field at a given point. With the help of that, I'll come to know that where I am. It's having, for us, we are on surface of the earth, no problem. But if you're in sea or ocean, no, or if you are in a pilot something, this magnetic field becomes very, very important. And also to predict the weather forecast. All these are very essential. That's why long back, from 500 years back, the Western people were behind this. And they brought several methods. So how to get horizontal component of Earth's magnetic field? By using the vibration magnetometer. Dip is measured using the dip circle. Declination, I'll measure angle made by the suspended free bar magnet with the geographic median. Okay, got this. This is the thing. So now with the help of this, I know this one. So what is now actual B? I'm in a better position. So what is BH now? BH we know equal to B into cos delta. So what is value of B now? BH by cos delta. At a given point, what is the magnetic field? Yes, I'm able to predict here now. So this is one separate instrument, this is one separate instrument, theta is separate instrument. Like this, by using all three different instruments, I'm able to predict the field at a given point. Okay, now what happened? Now the technology got improved. Some 40 years back, at every point on the earth, what is the magnetic field? Even at a height up to 500 meter or up to 1 kilometer, we know what is the magnetic field. The charts are available. Slightly variation is there because 11.3 degrees. When do we can see variation? Maybe after, for every 100 years, we can see that variation. So therefore, what all I prepared chart some 40 years back, still it's applicable. But sir, you only said this axis is rotating magnetic axis. Appreciable change will be noticed only after, for every 50 years. So 40 years back, it was updated. So every 50 years, they're updating the chart. And the charts are very important for the like a voyage in the sea, or for the flights, for the weather forecast, everything. So it's everything, one systematic science is there. For that purpose, we are studying this one. Okay, now how to calculate the, if you vertical component, as after knowing the dip, no? So what is BV? So what is the total magnetic field? So these are the things which are there. So this all small information I given are very important. These things, geographic north, OA2, and this surface of the earth, OA1.